Before we start anything, I just wanted to dedicate this page to a nice little review of trig identities. So these are the ones that you're definitely going to need to know in order to do these integrations that are following. So if you ever get stuck on your identities, just come back to this slide to refresh yourself. One of the common types of integrals that we'll have to do involving trigonometry is integrating products of powers of sine and cosine. So that would be functions that have the form the integral of sine mx cosine to the power of nx dx, where m and n are integers. Now there are a few cases of what can happen. Case 1 is that m is odd. In that case, what you can do is strip out, per se, one of the signs. So that means you would do something like this. You have sine to the power of m minus 1 x times sine x times cosine to the power of nx dx. And the reason we do this is now we have m minus 1 as an even number, so we can convert it using the trig identity sine squared x equals 1 minus cosine squared x, giving you the integral 1 minus cosine squared x to the power of m minus 1 over 2 times cosine to the n times sine x dx. So with these two terms, we have a polynomial in cosine x, meaning that you can let u be cosine x, and then du is negative sine of x dx. And so that gives you a polynomial in u, and then a du right here, so that you'll always be able to integrate. Case 2 is really similar. It's that n is odd, and so you can strip out one of the cosines, leaving you sine m to the x cosine to the power of n minus 1x cosine x dx. And then using the same trick, you'll turn this into a polynomial in sine, and then you can use u substitution, except this time u will equal sine of x and du equals cosine x dx, and you'll be able to integrate. Case 3 is that m and n are both odd, and when that happens, you can do either of the instructions given in cases 1 and 2. And case 4 is that m and n are both even. And unfortunately, when this happens, there's no set way to solve the problem. You'll just have to try to play around with your sine and cosine trig identities until you can get something you can integrate. When we're integrating powers of secants and tangents, we have something really similar. Again, we have the integral of, so it'll be tangent to the m x times secant to the power of nx dx. And again, we have different cases of what can happen. Case 1, if the power on the tangent is odd, so m is odd, then what we can do is strip out a tangent along with the secant, meaning we would have tangent to the power of m minus 1x, secant to the power of n minus 1x, and then tangent x, secant x, dx. Now this allows us to convert these tangents into secants, and then we can just set u equals secant x, du equals tangent x secant x dx, and so now we can easily see a polynomial in u and then du right here so that we can integrate. Similarly, if n is even, then what we can do is pull out 2 of the secants this time. So that would leave us with tangent to the power of mx, secant to the power of n minus 2x, secant squared x dx. And then we'll convert our secants into tangents, leaving us with a polynomial in tangent and the derivative of tangent right here. And in the case where m is odd and n is even, then you can choose either of the above strategies. But if m is even and n is odd, then there's no set method and you'll just have to play around with it again.